Given an array of positive integers nums and a positive integer target, return the minimal length of a subarray whose sum is greater than or equal to target. If there is no such subarray, return 0 instead. In example 1, the target is 7, and the smallest subarray whose sum is greater than or equal to 7 is this subarray right here, 4 and 3, because 4 plus 3 equals 7. So the length of this subarray is 2, and that's what we want to return in this test case. In example 2, the target is 4, and the smallest subarray, in this case subarrays, that equals or is greater to 4 is this subarray here and this subarray here. Either way, the length of those subarrays is 1. That's what we would return here. In example 3, the target is 11, and the entire array, when you add all of these ones up, there are 8 ones altogether, that equals 8. 8 is not greater than or equal to 11, which is our target, and therefore we don't have any length subarray to return, so we return 0. The test case we're going to use to solve this problem is this array here with this target. So our target is 7, and then our array is 2, 3, 1, and 6. So we're looking for a subarray whose sum is greater than or equal to 7. If you were thinking of using a sliding window approach to this problem, you'd be correct in doing so. That's the approach we're going to use to solve this problem. So we'll start with 2, and we'll say, is 2 greater than or equal to our target 7? No, it's not, so we will slide this window open and now include 3. 2 plus 3 is 5. Is 5 greater than or equal to 7? No, it is not, so we'll slide the window even a little bit more to 1. 2 plus 3 plus 1 is 6, which is still not greater than or equal to 7. And then we slide the window open a little more, and we finally get to 6. Is 2 plus 3 plus 1 plus 6, which gives us 12. Is 12 greater than or equal to 7? Yes, it is. So we can now set our min length to 4. So what we want to track here is the sum of our current subarray and the length of the smallest subarray whose sum is greater than or equal to our target. In this case, is 7. We'll call that min length. Right now, our sum is equal to 12, and our min length is equal to 4. Keep in mind that this subarray is the first subarray whose sum is greater than or equal to the target. That's why we've set our min length equal to 4. But what should we set our min length before the first length of the subarray whose sum is greater than or equal to 7? Should we set it to 0? Should we set it to 1? What should we set it to? And in our solution, we're going to set it initially to infinity. You might be thinking, well, I've never set anything to infinity in code before. Why would we do that? Well, the first subarray we find that has a sum that is greater than or equal to 7, we need to compare the length of that subarray to the current length of our min length variable. If we initially set it to 0, well then no subarray length is going to be less than 0. That's why to start off we set it as infinity, because no length is greater than infinity. Therefore, when we compare min length's current value, which at the beginning is infinity, to the subarray's length, the subarray's length will always be less than infinity, and therefore it allows us to set the first subarray length that has a sum that is greater than or equal to 7, even if it's not the smallest subarray in the array. Okay, so min length is now equal to 4. Because we're comparing this length here, 4 to infinity, we're saying which one is smaller, Of course, 4 is smaller than infinity, so then we replace our min length with 4. Now what we'll do is we'll start to close the sliding window. Right now our sum is 12. Because 12 is greater than or equal to 7, we want to slide the window over 1, leaving us with the values 3, 1, and 6. And when we add up 3, 1, and 6, what do we get? We get 10. So basically, we're subtracting the value that we slide away from. This gives us 10. Then we say, is 10 greater than or equal to our target 7? Yes, it still is. So we look at the length of our subarray, whose sum is greater than or equal to 7, and we count how many elements there are in this array. 1, 2, 3. There's 3 elements in the array, so therefore we will set the min length equal to 3. And because sum, which is 10, is still greater than or equal to 7, what we'll do is we will slide this window one more element and remove 3 from the sum, leaving us with 7. Is 7 greater than or equal to our target, which is 7? Yes, it is. It is equal to 7. So we will count up the length of our current subarray, which is 1, 2, and we will set that as our min length because 2 is less than 3. So we'll set our min length to 2. Then we want to slide this window one more element over, leaving us with 6. 7 minus 1 is 6. Is 6 greater than or equal to our target 7? No, it is not. We can no longer slide the right side of the window anymore, and therefore we are done with this problem. And we can return the output, which is the number 2. Let's take a look at the space-time complexity of this problem. The space-time complexity. The space complexity is big O of 1. And the reason it's big O of 1 is because we have a few variables here, like sum and min length. However, as our input array, nums, increases in size, sum and min length stay the same size in terms of memory allocation, regardless of the size of the input array. Therefore, our space complexity is constant O of 1. Our time complexity is big O of n. And the reason it's big O of n is because, again, our sliding window approach will be implemented using left and right pointers. So we'll use an outer loop for our right pointer to slide to the end. Then we'll use an inner loop where our left pointer may slide to the end. In this case, it did. However, in certain cases, it may not slide all the way to the end. But in the case that it does slide all the way to the end, we have a time complexity of 2n, right? 2 loops that iterate through the entire nums array. However, when calculating big O notation, we always ignore constants. So we are left with a time complexity of big O of n. So here is our space-time complexity. Now let's jump into the code editor and solve this in both JavaScript and Python. Let's start with JavaScript. So the first thing we'll do is declare our variables. Let sum equal 0. Let min length equal infinity. Then we'll open up a for loop. For j equals 0, while j is less than nums.length, j++. So this for loop acts as the right side of our sliding window. Inside this for loop, we want to immediately set the sum equal to the sum plus nums at j, right? Because that is how we're going to eventually tell if we have a subarray whose sum is greater than or equal to the target. So first we say sum equals sum plus nums at j, right? Which can, in shorthand, be written out as sum plus equals nums at j. Then we'll open up a while loop. This while loop will serve as the left side of our sliding window. The while loop will say while sum is greater than or equal to target. In here, we'll check if the current value of min length is less than the value of our current subarray's length. And we want to set min length to whichever is smaller. So min length equals, and we can use the math object here in JavaScript, math.min. So that's a method on the math object. And we'll pass in both min length and the length of our current subarray. The way we can get that is saying j minus I plus 1. And you might be wondering, where is I coming from? Well, we actually should declare that and initialize it up here. Let I equal 0. So now if we had, for example, 2, 2, 3, and our target was equal to 4, it's only when we get to this point where we've added up 2 and 2 to get 4, where our sum is then greater than or equal to our target being 4, which we then execute this line of code. In this case, j would be equal to 1 and I would be equal to 0. So 1 minus 0 equals 1, plus 1 equals 2. So this right here is giving us the length of the subarray, which is this. After setting the min length, we want to remove nums at I from the sum. So we will say sum minus equals nums at I. And then lastly, we want to increment I by 1. That's the same as sliding the left side of the window over one element. And when we're done with the for loop and the while loop, we return the min length. Let's go ahead and run this to make sure it works. Wrong answer. Okay. Oh, right. Okay, so in the case where all the elements in the array does not equal or is not greater than the target, we want to return 0. Instead, we return infinity. So what we can assume is that if our min length is equal to infinity, it means that there were no subarrays where the sum was greater than or equal to the target. So if min length is equal to infinity, we can return 0. Else, we want to return min length. Let's go ahead and run this to make sure it works, and then we'll submit it. Lastly, let's remove these comments here. Just tidy up our code and submit. Okay, great. Let's now move over to Python and solve it there. So again, what we want to do is immediately declare our variables. I equals 0, sum equals 0, min underscore length equals, and the way to set infinity in Python is float inf. So that will give us infinity. And now we can open up a for loop. So for j in range of the length of nums. So that's the same thing as saying, for while j is less than nums.length, we will add nums at j to sum. So sum plus equals nums at j. Then we want to open up a while loop. So while target, or while sum is greater than or equal to target, we want to check if the current min length is less than the length of our current subarray. So min length. And then we want to set the output of that equal to min length. So min length equals, and in Python, there's a built-in method called min. We can pass in two values there, min length and j minus I plus 1. Then we'll remove nums at I from our sum. So sum minus equals nums at I. And then we will increment I by 1. And in Python, the way to do that is I plus equals 1. After both while loops are finished, we want to return. If our min length is equal to infinity, we want to return 0, else we want to return min length. So we'll say return 0 if min length should be min underscore length. If min length is equal to float infinity, else we want to return min underscore length. Let's go ahead and run it. All right, so the 3 test cases pass. Now let's submit. All right, great. That's how to solve minimum size subarray sum.